That's section 7.1, but it leads directly into section 7.2. So we're going to just shift right on into section 7.2 then, multiplying and dividing rational expressions. When we multiply rational expressions, here's our procedure. We factor the numerators, factor the denominators, and cancel out common factors, factors. That might look familiar to you, and it should, because just a couple slides ago we had the same thing for simplifying expressions. But notice the difference here. This is a single numerator, a single denominator. When we're multiplying expressions, we're going to have more than one numerator, more than one denominator. But that's the only difference. There'll be more factoring, but that's it. Okay? So let's take a look at one. Pop over here to the Paint program again. No, I don't need to save it. Okay. Let's get the polynomials, the rational expressions. We'll keep it simple. X squared plus 1x over, let's say we have x squared minus 2x minus 3. And we're going to multiply it. You can have either a dot or an x. I prefer the dot because an x multiplication symbol can look like a variable x, so we try to avoid that. So let's multiply that by, let's say, oops, I don't need that. Come back over here. Let's multiply that by x squared minus 9 over x squared plus 2x plus 1. Okay? Alright. What's our process? Our process says to factor numerators this time, plural. So we look at just work on the numerator one part at a time. I have this numerator factors to x and x plus 1. This numerator, we recognize the difference of squares. That's going to be the roots with the same function and then the roots with the opposite function. Okay. Now down here, that's factor the numerators. Then we factor the denominators. Oh, we're done with these now, so we can cross those out. We factor the denominators. We want the factors of 3 that subtract to be 2. Well, that's going to be 3 and 1. The larger one gets the same sign as the b, the other one's opposite, so that they subtract. So we're done with that one. And then over here, we want the factors of 1 that add to be 2. So that's a 1 and 1. Same sign for the b, same because they need to add. And then we can notice, oh, well, that was a perfect squared trinomial. So you see what I mean about having it factored before you even recognize it. So, alright, here we go. We've factored the numerators, we've factored the denominators, and now we cancel common factors. Well, what's common here? We have a x minus 3 over here, and we have an x minus 3 over here. Does it matter that they're coming from different fractions? Absolutely not. Remember, when you multiply fractions, you just multiply straight across anyway. So all these numerators come together, all these denominators come together. So it doesn't matter that you're going from one fraction to the other. What does matter is that you always go from numerator to denominator. So this x minus 3 in a denominator can be canceled with an x minus 3 in a numerator. That's perfect. Those are gone now. Then we look for other common factors. And you might say, oh, well, there's a common x plus 1 and a common x plus 1. But you can't cancel these ones because they're both in a denominator. Canceling has to occur from numerator to denominator. You cannot cancel things from denominator to denominator or numerator to numerator. It has to be numerator to denominator like that. Alright? So those are canceled. And then whatever's left is your answer. There's an x remaining over here, and a lot of people will miss that. Like normal, like everything else we've done, it's those single variables or the single numbers that are factored out that we tend to forget about. So make sure you don't miss those. And then an x plus 2 over here over x plus 1, and we can say x plus 1 and x plus 1, we can just square that like that. And this is done. You don't need to multiply it out. In fact, I like it when you don't multiply it out because it prevents you from making a mistake when you multiply it out, and I get to see a little bit more of what you were doing even when you have an error. So now, can we hit this x and that x? No. This x is a factor. This x is being multiplied by that quantity. This x is a factor, but this x is not. It's being added. It's an addend. It's not a factor. Okay. Let's look at another one real quick. Let's say we have let's get another color. Make it a little bit interesting there. We have x cubed plus x squared over x minus 1 times again, we'll just keep it real simple here. X squared minus 1 over x cubed. Yeah, we'll make it cubed. Minus x squared. Minus 2x. There. Yeah, that's what we'll work on. Alright, let's factor the numerator. So we have a common x squared here times x plus 1. And let's throw a little bit of something extra in here. Let's say we have a 2 right here and a 2 right there. So we get a common 2 out here. Let's keep it the same color. Okay. Alright, so back to the writing, and I think, yeah, we have this. So I have a common 2 there. And then let's make this one 4, like that. There we go. Alright. That'll make it a little bit more interesting. Okay. So we factor the numerator. Alright, we got a common 2x squared now. We factor that out, leave us with the x plus 1. We got our difference of squares over here, so that's x minus 1 and x plus 1. So that's done. We've got a common 4 over here, so that leaves us with the x minus 1. Okay. And then over here we have we have a common x. We pull that out first. So that gives us x squared minus x minus 2. So we're done with that, but this can still be factored. We have the factors of 2 that subtract to be 1. So we still have that common x out there. And then we have 2 and 1 for the factors. The larger one gets the same, the other one's opposite, so they subtract. And now we're done with that one. That one doesn't exist anymore, we factored it. Okay? Then we look for common factors. We factored the numerators, factored the denominators, and then cancel common factors. Well, we have a common x plus 1 there and there. We had it up there too. We could have hit that one just as easily. We have a common x minus 1. Anything else that's common? The ones that people forget. We have a common variable here. We have a common x with this x squared. X squared means there's 2 x's there, right? So but we only want to cancel one of them, so we could cross it all out and write an x above it, or just hit that exponent. Now there's only one x left, right? When we hit that exponent. Anything else? Yes, absolutely. You may have noticed these numbers here, the 2 and the 4. Remember, rational expression is anything that can be written as a fraction. So 2 over 4 can be reduced to 1 over 2, just like the fractions you've been doing for quite a while now. So our answer then is whatever's left. What's left here? We have an x and an x plus 1. So x times x plus 1 over, we have a 2 and an x minus 2. Boom. And that's it. It's all done. Okay. So multiplying rational expressions is almost identical to simply simplifying expressions, because all you need to do is factor two numerators and two denominators instead of one numerator or denominator. Okay? Otherwise, it's exactly the same. All right.